Good morning, good afternoon, good evening. This is Rich Bowers, and welcome to Corporate Bytes. Today, I am absolutely thrilled. I have returning guests Charles and Jamison, data, machine learning, and overall learning and development experts with me. Good for us. Good afternoon, gentlemen. How are you doing?
Hello, good to be back, Rich.
Hello, it's good to see everyone. It's good to hear from everyone again.
Well, thanks for coming on. And last time I had both of you guys with us, we talked about GPT. And
Yes.
sticking kind of in the same area, we're going to go generative AI overall. And we spoke a month and a half ago, 2 months ago or so, and there's been so many more changes and updates and enhancements and new players into the field, it seems like too, that we thought that now is a good time to do a little catch up, right? So if that works for you guys, I have a first question for you. We're going to take it back a little bit. And I don't want to assume that everybody listening knows the term generative AI and what that means. We all have heard of Chat GPT at this stage, but maybe we go a little bit deeper into what generative AI is and talk about how it's created and how the outputs exist. So, um, Charles, do you want to kick us off a little bit? Do you want to explain in your own words, what is generative AI and its applications?
So, in its most general sense, a generative AI is a tool that generates content based on a prompt. You have a you give the generative AI some kind of input and it creates content based on that input. One a tool, a generative AI tool that has actually been around for quite a while now is autocomplete. Autocomplete on your phone. That is an example of generative AI. It looks at the previous word in a sentence and says, okay, here's what is probably going to come up next. And the difference in what we have in what has been kind of exploding in popular discussion, popular consciousness in the last, in well, this year, I guess, is the idea that autocomplete can look at classically autocomplete looked at your previous sentence, the previous word, or the previous sentence, or the previous code block, for example, and then said, okay, here's what the next word is probably going to be. Now we have tools that can look at the previous paragraph, the previous several paragraphs, and predict what the next paragraph is going to be, and then generate it for you. So in a very broad sense, that is what we're talking about with generative AI. So as I mentioned in the last podcast, artificial intelligence is actually a very broad term, and it includes everything from ChatGPT to a binary sort algorithm. Technically, those things are all classified under artificial intelligence, but when we're talking about it in in the context that we're talking about it, it is things that will these generative AIs are going to be things that take in a prompt, generate a large amount of relevant output. And I'll turn it over to Jamison, see if he has any input on this definition as well.
Yeah, no, that's great. With the autocomplete is a perfect basic example of that with generative AI for sure. I would just add in that the advent of deep learning is pretty much what's leading the charge with this newer wave of generative AI with ChatGPT and image generators and music generators as well. Even these are all deep learning models, right? So these are using more advanced computations, larger architectures within these models, and they're doing the majority of the work here, And they've recently gotten efficient enough and large enough that they're able to handle a very large amount of data and be able to reproduce human-like outputs. And that's pretty much what's leading this most recent charge with generative AI.
Pretty thorough definitions there, and insight. Thank you both. So in one quick, if we could sum it up in there. So it produces words, phrases, sentences that are likely associated to come next, right? And kind of encapsulation wise. So how does that happen? I know Jamison went into a little bit of deep learning pieces, but as a large language model, how does all that work? How do they get those predictions? Where do they come from? And how does that go? Maybe we go in reverse. I know, Jamison, this is something that you and I have talked offline about. Can you kind of walk us under the hood a little bit more?
Yeah, so at its heart, these models are basically prediction algorithms, large language models in particular, but we'll go ahead and work backwards a little bit from deep learning to a particular machine learning algorithm called it's called a perceptron. And this is basically just a very simplified version of a neuron, right? And the metaphor basically stops at it's taking input, it's doing a particular computation on it, and it is outputting a particular value, right? And so that's just one single perceptron. And where neural networks come into play, where deep learning comes into play, is when you start adding multiple perceptrons to that mix, have them doing their own unique individual computations, and then sort of summing up all of that output into something that is perceptible to humans and is actually useful. And that's where those models come into play. And so deep learning is having multiple layers of these perceptrons, these individual nodes, instead of just like one layer lined up that takes input and all of them take that input and process output. These individual layers will actually pass input to each other. And in different ways and forms, these different architectures have grown in the past decade or so, couple decades, with a lot of research, and have turned into the large language models that we see today through a series of both computational advancements and hardware advancements as well.
Okay, so you're talking about perceptrons, and between that sounds like Megatron. There's Transformers, and there seems to be a theme behind all of this. But you also mentioned neural networks. I'm very curious about that. I've been looking into it a little bit, still trying to see how it works. But Charles, I want to give you the opportunity to add to what Jamison mentioned. Do you want to add on to that?
Jamison was pretty thorough in that definition. One thing that I just kind of want to mention is that the effect of these tools that we see, that we kind of see in practice, it relies on two things that humans are uniquely bad at intuiting. That is statistics and scale. So when we so statistical output, statistical observation is actually a lot better than most people kind of intuit. Most people kind of like when you try to intuitively think about statistical likelihood, most of the time your first gut instinct is kind of wrong. So when we say that the machine is outputting a statistical likelihood, what is the most likely thing that's going to come next, it's that calculation is actually a lot better than you might think it is.
Does it take out the
And
emotion? Is that why you think with like statistical, like we think like, okay, cool, this should happen, or we just think it should without any type of realistic piece? Maybe it's a heartstring pull. I don't know.
Well, it's more like like the human brain kind of works really well at a certain scale, and that's the second thing we got to talk about. Like when we're talking like the scales of perceptrons is in like Okay, I don't know the exact numbers, but Jamison, what order of magnitude are we talking here? How many of these nodes are there in a given system?
Well, so in a single perceptron, that's just one neuron. So
Right.
if we're trying to equate it to like a human brain, human brains have like what, 60 to 80 billion
Yeah.
neurons. The architecture that we see now, I think, are approaching that size in terms of individual nodes, but the difficult part is actually the connections between each
Right.
node. And the architectures with that we can't really match that
No.
just yet. There's a lot more research to do in that
Yeah.
field before we can equate really any kind of human brain structure, like actual structure when it comes to neurons, to any kind of statistical model when it comes to this.
Yeah. So basically what I'm saying is that if you have a computer architecture doing billions upon billions of calculations per second, doing all of these statistical calculations, the human brain is just simply not equipped to think about all the math that is happening. And that's why we invented computers in the first place, to do all that math. So when you see this like incredibly clear output from a machine, that's still just the result of more calculations going on than your brain is really equipped to think about. So so these outputs seem like magical almost, but that's just because there's like stats are better than we expect them to be, and there's more statistics going on than we really think about in these models. And that's why the output is so good looking, essentially.
Hmm.
And that's kind of the point I wanted to make.
And that, I mean, that makes sense, right? I mean, that's the beauty of it all, is the speed, the ability, and the data, just the whole flow of it. So you guys kind of talked a little bit about it too, with comparing it to the brain, right? That's what neural networks are kind of based off of. Is that correct?
Yes. So, well, it's an attempt to model the human the architecture of the human brain, but I think it just really needs to be said upfront. The models are not that good yet. The models are not as good as the human brain at most tasks. But the tasks that it is good at, we can scale up much faster than we can scale up the human brain, for reasons that I should hope are obvious.
And so when we're looking at neural networks,
Yeah.
and this is something that we didn't get into the last time, and I think this is really probably a key area, right, for people to start kind of understanding, because Charlie, you're mentioning it could scale up. Obviously, we've kind of just hit the tip of the iceberg with the abilities comparatively, right? Comparatively. So if we're saying, is it safe to say the neural networks reflect somewhat, or plan to reflect the behavior of the human brain, with recognizing patterns and solving problems?
That is the
Goal,
goal.
goal,
That's the
right?
goal, but we don't know if but we don't know how, but right now we're not sure that we can scale a neural network to the scale that a human brain works. I was reading uh, I was reading a statement from OpenAI, and they were talking about that as they're rolling out GPT-4. They were saying they're not sure if their current architectures can scale to a meaningful GPT-5. Like right now, we have, with the techniques that we currently have, these colossal models, GPT-4 is as good as it's going to get for the foreseeable future. There needs to be some other innovation to scale it beyond what GPT-4 is capable of. So we're kind of hitting a point where we've had this explosive growth in the technology, and now the innovations that we have are going to be using GPT-4 at its current scale. And this is going to be with things like plugins, specialized versions of the models specialized for different things, like models for code versus models for human speech, things like that. So the idea of the neural network is to model the architecture of the human brain, but it's not quite there yet. It's not quite at that point.
Okay, and going a little more in the future, then Jamison, piggybacking off of what Charlie's mentioned, are we going to get there? Are we going to get there sooner than later? And what are your thoughts on that?
I think so. To me, the concept of the human brain is it's a series of different networks that are all dealing with different kinds of data, right? And if we're trying to equate that to what we have right now, then we need to start connecting more kinds of data to be able to either generate or predict or pretty much do anything that artificial intelligence does in a more human architecture. That's definitely gonna take more connection at this point. Like Charles said, we're kind of reaching a point where these models, the computation power of these models is getting to be too high for our current hardware, and the hardware isn't improving at a rate fast enough for us to be able to improve that the way that we want. So people are starting to turn more towards not just plugins and creating APIs that are able to communicate with these models from different applications, but being able to make connections between the models themselves and being able to make models that aren't necessarily meant to generate anything, but meant to understand the connection between two different modes. For example, natural language text, which is something that we use all the time with statistical models, and images, right? And we currently have particular models that understand the relationship between these two things. And we use those models to train generative models that will then be able to make something based on text that you give it, right? So that's starting to get pretty popular now too with image generation. You input a text prompt, which is natural language text, and the output ends up being an image, right? And that's definitely different than just getting natural language as output. And the architecture is quite different as well. And there's a lot that goes into that for sure. But I think the future at this point is going to be connecting these models, finding more sources of data, finding more modes of data, and being able to process those in a way that the model itself is able to understand. And it's going to take a while for us to get to something more of like a general intelligence is the term that people tend to use, artificial general intelligence. But people are already working on that. And I think at this point, the current idea is making models to train other models and using multiple systems to work together.
You actually just mentioned a whole bunch of things I plan to talk with you about here, right? I do want to talk about AGI as well, but taking a pause from the future and going back to, the areas that we didn't get to hit on last time was kind of the ins and outs of generative AI. And you hit on training and, the way other models can help train other models. So can you explain to me, just to start, maybe we go to Charlie on this one. How is the data coming in? How is it trained to produce or predict what is the output? And then maybe after that, Jamison, maybe you go into scaling supervision or along that lines. But Charlie, do you want to kick us off there?
Yeah. So sure. So these models are trained on, well, they're trained on the internet. They're trained on massive data sets of natural language that people have used. They're trained on books, they're trained on newspapers, they're trained on articles, they're trained on conversations. So they're trained on all of this big data that we as a civilization have been producing for, well, thousands of years, hundreds of thousands of years. And so when again, we're just think about the scale here. We have a system that is able to look at natural language from the beginning of human history and calculate what words precede other words, what paragraphs precede other paragraphs, what phrases precede other phrases, and so on. And as these models scale up in processing, we can not only have that, we can also have like what bits of an image are related to other bits of an image, and what tag and what like natural language is associated with an image that has this other map of relationships. So these models are trained on huge amounts of natural language, and also human input from its output. And this comes in there are two main sources of this. So the phrase here is human reinforcement learning. I may have gotten that phrase slightly wrong. Jamison will correct me. But it's basically the human reinforcement aspect is you have outputs that humans then respond to. For example, I'm sure that people listening to this have had to use CAPTCHAs to log into things, where you have says, please click all images that contain a motorcycle. Please click all images that contain a basketball. And you may have noticed that recently some of those images have started to look a little off, a little weird. Well,
yeah, by the way, I just got one earlier today that was which version of this toad is facing upright, and it looked like it was just a piece of clay. It was very odd.
Yeah. And that's because those are all generated images, and they are relying on you to do the human reinforcement of that. So please, to prove you're not a robot, what are the letters in this text? And they're saying, okay, that's an image that's associated with this letter. So a lot of these login systems that we've been doing for years have been free training for these AI models to understand what natural language is associated with what image, what natural language is associated with what letter, things like that. So that's the one source. So the primary source of training is just a huge corpus of, that's the term for that. There's a huge corpus of text. And then to refine the output, we have human reinforcement. And we're either outsourcing this to humans, to like the general public, or to people who they pay to read all of the output and mark it as correct, incorrect, offensive, or inoffensive. And that's how they're able to, they're just saying, so, because remember, the model doesn't know anything. The model doesn't actually know. It's just making a prediction. So if the most likely response to a prompt is something horrible that no one wants to see, you just have to have a human being tell it that result is horrible, and add a bunch of statistical weight so that a response like that never gets spit out. So there is some potential there is some potential controversy in how these in how the humans who weigh this do their job are asked to do their job, but that is how these models get to where the outputs are going to be appropriate. As of right now, there's still no way for a model to know that. There has to be that human element. There has to be that human reinforcement element.
Got it. So to fine tune
Mhm.
all of this, right? They train on a reward model. I've heard it pop up as, right, and then they optimize through this reinforcement learning,
Correct.
right? And then you're also then kind of leaning into maybe that question that I asked Charlie is right now there are a lot of humans are kind of doing this reinforcement,
Hmm.
but in different weights, right? And I think that kind of I'm kind of thinking neural networks again when I think about weights with
Yes.
the nodes, right? I believe.
Hmm.
So do you want to pass that baton then to Jamison to go the other route? So we talked about the human ways that it's trained in currently.
Hmm.
Where's this going, Jamison?
Yeah, so let's see. I think the term Charles is trying to think about is reinforcement learning from human feedback. So the human aspect is great. I think human reinforcement learning is perfect too. But basically that's the focus for that, right? Is human based. You're using human feedback to tune that model after having trained it um, on a huge data set, right? So you're trying to make it respond in a way that is acceptable to the people that are tuning it. And that's a little bit where some of that bias comes in, right? And some of that human bias. So an alternative, which a couple of different companies are looking into, is reinforced learning with AI feedback, which is essentially the same thing, right? Whenever we're trying to automate a process, we're starting from the most basic layers. And once we get to something like this is where the human part usually comes into play, right? So coming up with a model that is able to understand good feedback, bad feedback, whether this is acceptable or unacceptable, what can be tweaked, and using a model to actually tune another model. That is the objective of a few different companies like Anthropic, who has recently released the Claude model, and that is actually based upon constitutional AI. And this is where the whole sort of iterative supervising and scaling of that entire process comes into play when it comes to automating it. And with constitutional AI, this model that is training Claude, I believe, is actually based upon a foundational constitution, and that's where the constitutional part comes in. And based on this constitution, and obviously this constitution can be changed and the model can be retrained based on certain governing principles, right? But based on this constitution, this model will train Claude or other language models to generate particular output and automate this process so that humans don't have to do this, or so that we can eliminate the bias that certain groups of humans might have in this process.
Great. And in the term, for instance, with Claude, they're helping out with on the ethics and pitfall sides, right?
Mhm.
So, but going to the scaling supervision, this is something that I was fascinated about. Right now, they're doing it, but AI is helping humans along the way, right? Kind of as training wheels, maybe. I just don't know who's driving in this situation. But the game plan is to train this and reinforce this so well that all of a sudden no humans are needed and they're able to make the adjustments themselves, the machine to machine. Look, Charlie's giving me a face that I'm not 100% right. Do you mind clarify, please? Definitely.
Well, I think there's an inherent contradiction in that. There's an inherent contradiction in the idea, oh, the machine will be able to figure out what is the appropriate response to a human. But where will it get that information? Like, yes, you can automate this process. You can automate this process. You can automate every step of this process. But the foundation is always, what is an appropriate response for a human? A machine can't know that. A machine can't know that any more than if you walk into a Starbucks, the barista automatically hands you the coffee you want, because they don't know that. They don't know, like, there has to be, at some layer, human input for what the machine is trying to optimize towards. You can't just never have human input, because that a system like that just simply wouldn't make any sense. There's no way to completely remove human interaction, because ultimately it is for humans, right?
Does it become a point where we're so predictable that that could happen? I'm just not.
Well,
I know normally I have a yin and yang with you too. So
yeah.
I heard the well though. What do you think?
Humans are another thing is that's frankly disturbing. Humans are a lot more predictable than anyone is probably comfortable thinking about. So
Yeah.
there is that aspect. Like, statistically, human your actions are actually more deterministic than you might think you're the master of your own destiny, but at a certain point, eh, as we've seen in a couple of infamous incidents involving some early machine learning exercises that I'm sure you could think of a couple, human behavior in large groups is extremely predictable. So more so than probably anyone is comfortable admitting to themselves.
I'm going to tell you, anytime I get a message from Amazon recommending me a new book, I know I'm just going to buy it. Just put it in my cart, hit the credit card button, and it's at my front door. So then you're kind of leading into almost my question, or my thought is, are we predictable enough that there may be, maybe not zero, but a very small percentage, Jamison?
So the way that I see it is we're basically building up a pyramid here, right? A pretty big pyramid, and the taller it gets, the more precarious it becomes, right? But every layer that we add onto that, the more attention we have to make sure that we're paying to each and every individual layer below it as well, right? So we can automate these processes as much as we want, and we can get to a point where we're basically doing what we do every day with AI integrated with everything. And that will give us a chance to, again, I love this metaphor, reach for new heights when it comes to being a person, right? And just being able to express yourself and create things that are new, because that's what humans are drawn to, right? Is novelty. And especially with the level that we're at with AI, it's given us a lot of opportunity to get rid of those menial tasks and start working on things that actually really matter to us. And I think even with that in mind, even with the layer that we've abstracted artificial intelligence to with our progress here, we still have to take into account every single other layer that it's built on. And if we don't do that, everything pretty much falls apart.
So I see what you're saying, and you can probably guess what side I think it's going to go, right? I'm reading this book called The Chaos Machine. It's a little bit newer book. I don't know, James, I know you're a big bookworm like myself. And basically what it's about is the algorithms running rampant in social media and other results. And I don't need to get into all of that. But one of the things that struck me was they don't know how it's working in certain areas. And so, as we're all big comic book fans, right? Who's watching The Watchmen in this type of situation? Charlie's going to potentially correct me on that later on, I know. But in reality, if it's not already happening here, that's my quick thought process. So that's why I'm certainly interested in Claude with the constitutional AI that has those built-in ethics and platforms. So super interesting. I don't want to get too futuristic yet because I know we're going to go into AGI, which is a pretty cool topic. But before we depart our current situation with generative AI, Charles, Jamison, you guys talked about Chat GPT-4, right? Can you just give us a quick little highlights overall about, maybe there's longer context, right? They could do 25,000 words or something like that. There's images and all these plugins, and it's connected to the internet now. Can you just give me a little bit of details about some of the improvements, the advancements, and maybe very short-term or near-term applications that we can use with it?
Yeah, sure. Yeah, I've been able to play around with ChatGPT a bunch. I think for starters, so just to understand the difference between what ChatGPT is and what GPT-4 or 3 or 2 or even 1, those are all models, right? So GPT is generative pre-trained transformer. So it's the transformer type of architecture. That's a specific model that sort of understands attention and memory to a particular degree. But it's generative as well, right? So this is what is the pre-trained aspect here is what is used to fine-tune to more precise applications like ChatGPT. ChatGPT is, I would define ChatGPT more of as a chat bot. But that would basically be just for starters. But in terms of functionality, ChatGPT is actually pretty great in terms of just like being able to start from a big picture and scope down sort of and focus on particular aspects. And I think some of the newer improvements here that really help with this are plugins. Since I've been able to access ChatGPT Plus recently, so I've gotten to take a look at some of the plugins that they have, and they have stuff for these are all third-party plugins, by the way. So somebody is actually coding out the APIs for this that is actually telling the model what to do with particular pieces of data in the application. But I've seen stuff from shopping to generating more perfect prompts to getting sources for particular articles or generating figures out of data, all of that kind of stuff you can use with plugins. So again, I talked earlier about being able to connect this to applications and other models, but this is sort of the beginning of what we're going to be able to see with other models as well, especially with other tech corporations that are throwing their models into the game. We're seeing them integrate a lot more with their platforms as well, such as with Google. We saw in Google I/O's conference recently, they announced that they're going to be integrating their language models with search and with all of the other applications as well that they use, like Gmail or Docs, all that kind of stuff. So as a content creator, I'm super excited for that.
Jameson, I think you see my notes when we do these. You're spot on here. Yeah, no, and Microsoft with Copilot, as well. It looks incredible. I think one of the things that I was most impressed about is they can summarize groups of emails. Now I know you've been spending more time on ChatGPT, and I think Charles, you've had the opportunity to, segueing from what Jamison just mentioned, spend more time with Bard. What were some highlights that you saw or that you noticed from the I/O?
So I have, I apologize in advance for this, but I have some nice things to say and some criticisms of how Google is moving forward with this.
That's why we love you on these things, by the way.
Thank you.
So
Thank you. Yeah. So one thing, now we mentioned this already, and it's not specifically from Google, but one of the things that I'm definitely most excited about is, at least for my job, is Copilot, GitHub Copilot X, because what it will allow developers to, it will allow like people who have to write code just so much faster, just so much more efficiently. If you need to generate unit tests, and if you're in the audience and you're not a developer, unit tests are very tedious to write because you have to check every single edge. You have to check, every single edge case for like what could happen if code for if this code runs, what happens when XYZ happens, and then K happens in production and the whole thing burns to the ground. So being able to generate those kinds of being able to generate code, being able to generate unit tests, being able to expand on like being able to just generate, hey, I need to generate a backend that handles data, like read, write, update, delete operations from this model. I write the model, and then the bot writes the database interactions. And just being able to like auto generate that, auto generate coverage, all of that is going to be so beneficial for developers. And Google, at the Google I/O conference, they announced also a version of that. They announced their own code assistant, which they called Cody. So a good name for a code assistant. And I'm still going to complain to Microsoft that they went with GitHub Copilot X instead of bringing back Clippy. Like this would have been the perfect time to bring back Clippy, but they have not brought back Clippy, and that's disappointing. But
Yeah, and by the way, before you get to it, I know I'm sure you all listened to our microbytes that I had with Matt where we went through Copilot. Did you
yes.
have a chance to see the voice activated piece that it's doing? That was quite impressive.
Yes.
Across the board. And so just talks and types for you. It can pull data and it can create different charts and graphs.
Yep.
Right. So
Very
Charles,
impressive.
sticking with you here, because also you mentioned how these code assistants, right, with generative AI here, can be very beneficial to junior developers. And I think first thing that every single person talks about, and we have before, is displacement, right? Job displacement. Are the roles of junior developers going to become extinct? And and I think now it's kind of settled down from maybe even when we talked a few months ago. Quick little stats, and then I'd love to hear your comment. But there was a stat that said artificial intelligence is going to displace 85 million jobs, but create 97 million new ones. It's going to affect over 300 million current roles. What is your take on these generative AIs as code assistants, either replacing, enhancing, or however you want to describe it?
I would say that there's a risk that it will definitely enhance existing jobs. Using GitHub Copilot will definitely there was a poll, GitHub Copilot users overwhelmingly found it helpful in their jobs. I still think there's a potential risk in that it will replace new jobs, just because a lot of the things that you hire junior developers to do, it can just do. Like writing those very basic backends, that's the role of a entry level. That is what you hire entry level talent to do, and now you don't have to. So I do think there is a risk that it can genuinely replace a lot of these. That it will genuinely be used to replace a certain number of jobs. Just if you have the kind of coder whose job is to write code, like the copy editor equivalent of developers, these tools can replace them. But in the role of, for someone who's like a developer, someone who is building systems, it is absolutely going to help in that regard.
Cool.
So,
and to drive in your point also, that GitHub survey, so I think it was 60 to 75% of users feel more fulfilled and less frustrated when coding. And then there was even an 87% of those surveyed felt that GitHub Copilot, when it gets to its potential, and even right now, preserve their own mental health because they're avoiding doing repetitive tasks over and over again.
Yeah.
So for those that can use their critical thinking, their agility, their own taking initiative and passion, so to speak, right? All these mindset terms and all that stuff. Those are the ones that are responding to this survey. That
yes,
correct?
I would say, yeah.
So the Jamison, do you want to add on to there? I know you have some great points on this too.
Yeah, sure. Yeah, I would say that it definitely poses a danger to junior developer jobs, just specifically because the duties are definitely going to shift, right? We've automated particular duties, so new duties will arise, and if the developers can't rise to the occasion and perform these tasks, then yes, they will be let go in most cases, I would say. But I think it poses a danger, but at the same time, it also offers a helping hand because this isn't just here to replace your job, it's here to lift you up, right? And you can use it to dig into a particular niche subject if you're either on site or if you're still learning. You can still look into particular things that are still developing. And with the use of these language models, you can really excel at the current job and be able to establish, even automate your own tasks, right? And that makes things a lot easier, I think, for sure. But I would say there's a bit of salt, but there's definitely a lot more sugar in the mix.
Nice. That was great. Yeah. So it seems like we're at a consensus here, right? Is corporations are going to want to use this for remedial frontline tasks. They're going to use it. Frankly, it is what it is. It's going to be cheaper, right? It's going to be cheaper, faster. Charlie talked about all the computation power and all that stuff, and we all know that. And however, if you are the type of individual in any role, we're not even just talking about junior, we are for the moment, but this doesn't just impact junior level opportunities or positions, right? And it doesn't just impact those people in front of a computer even. And if you look at the different stats, and it's all over the place, I can't even give you an exact one because anytime I look up efficiency stats, they throw in different pockets of individuals or different data behind it. But at the bare minimum, I saw a 14% increase in efficiency at the bare minimum, just if you're able to partner with it. So if you're listening to this and you're concerned about displacement, it is kind of use it as a little bit of a wake up call, would you say, gentlemen, in terms of, hey, look, dive into this, use it as a code assistant, a generative AI as a collaborator, more so, correct?
Yep, use it to its full extent for sure.
Excellent.
One person who I was talking about it with described it as everyone gets a secretary. And if you use it like that, then that is so if you're getting into the coding field, you're going to skills that will be more marketable will be problem solving skills rather than coding skills. I think that's going to be I think that's going to be kind of a shift. I do think I will make the prediction. I could be wrong, but I do think it will overall shrink the number of developer jobs. I do think the number of developer jobs will go down, but the jobs that remain will be more valuable. So I think that like institutions will need fewer people sitting at a desk typing code into a computer, but the people who do that will be more valuable to the company, and those jobs will be better jobs than just the ones than the number of jobs that we have now. That's going to be like there'll be fewer developers, but they'll be happier at their jobs. That's going to be that if I were to make a prediction, that would be it.
And Charlie, always giving me great stuff to piggyback and follow off of here. Recent article came out that Bill Gates is someone that said that generative AI, one of the biggest values could be everybody's secretary. That was also right in line with it. So you and Bill Gates, same wavelength,
Oh,
at least in this
oh
area.
no.
At least in this area. And then also, I don't know if you know this, but Deloitte was a corporation that came on out saying critical thinking is going to be the major skill going forward. The
Yeah.
major skill, and innovation, I think, was a top 5 or so on top of that. So you're spot on there. Did you want to say something?
Oh no, I was just going to say, asking a generative AI, asking a code assistant to write code to to say, hey, write me code that does this. It's good at doing that. Write me code to solve this problem. Still not great at. It's not at. It's you have to be very definitive in what you want the machine, in what the kind of code you want the machine to write. You say, write code that responds to these inputs and produces these outputs. It'll do that perfectly fine. If you tell it to write code that will solve this problem, it's still not good at that. So you have to know how to solve this problem to tell the machine, write code that does this, and you keep track of how that's solving the problem.
And important to know for all of us, because this is a part of all of our jobs now already, and even more in the future, but specifically the skill of a prompt engineer, right? For those going into prompt engineering as one of those jobs that potentially and are being created, right? They're going to need to know, just instead of doing the basics of what the machine gives, how do you think through it? So, Jamison, that kind of gives me right to what I was going to lead into here is, Charlie and you were talking about these jobs being, maybe decreased, right? The amount of junior level jobs, but the new ones are going to be more valuable towards corporations. So if we're just going off of the stat of 85 million removed jobs, 97 million new ones, in your mind, what are those 12 million plus jobs going to be?
I would say, when I think about this, again, bringing back the little pyramid metaphor, those new duties that we tend to have are as that pyramid grows, right? So certain layers are going to, again, still need to be maintained, and we might actually end up having innovation still in those layers that makes them more stable or more efficient, right? So when it comes to prompt engineering, I see prompt engineering at the very top of that pyramid, right? And below that, we start getting into coding with making APIs for plugins for those models. Then we get into those actual architectures and training those models and understanding the software behind that. And then, of course, we get down to the GPUs and the hardware, which is a completely different job, right? So I think obviously those jobs are going to remain, and there may be new jobs that occur with innovations in those sectors. But when it comes to prompt engineering, I kind of see that as more of a skill that currently sort of embodies a good portion of a particular role's duties, right? And when it comes to actually using that and applying it in real life, I think it's so well generally applied that it's something that a lot of people can do, but it's still something that you can be skilled at, right? Like everybody knows how to search on Google, but it takes a lot of skill to be able to find something really, really niche using Google, right? Or just to look something up online, right? That's a particular skill. And this is, again, these models are particular tools that aid in these skills. And so being a prompt engineer and being on the top of that pyramid, I think involves staying up to date with that lower layer and being able to use those plugins and knowing what new applications are useful. I definitely see that interaction between those layers creating a lot of new jobs as well in both application development and remaining in application development, but with these new duties attached on.
And I think you put a nice little bow on this section. And it's just that, hey, look, there are changes. They are here. They are coming. You have to adapt to it, and you can't just kind of sit and say, okay, generative AI is going to do whatever I need it to do, and I don't have to worry about anything else, right? Other deep generative models, they're just going to do it for me. That doesn't work. You're going to get replaced then, right? So you have to work with it through our scenarios here. So really, really nicely done there. Now, our last section, if I could steal y'all for some more time here, you both kind of hit at it. AGI. So we're looking at artificial general intelligence. I know this is way in the future if it ever happens, and I don't know if we're going to get into what is it, technology singularity. If that ever comes, yeah. But I'm just curious. You both brought it up in whatever way you want to address it. Can you explain to me what AGI is, and kind of your view on it? Charlie, you want to go first? Yeah, you're ready for it.
All right. So, in mathematics, a singularity is, to put extremely simply, please, mathematicians in the audience, please don't yell at me for explaining this badly. But the concept of a singularity is where predictions no longer work on the other side of it. So if you're looking at astrophysics, you have a black hole, there's a singularity at the middle of the black hole, and it's called a singularity because our models fail on the other at that point. The singularity has too much gravity to be explained by quantum mechanics, and it's too small to be purely explained by general relativity. So it does not
Yeah.
uh,
Can you, so it does, I don't want to cut you off there totally, but just to make sure. So when you're saying it can't be, there can't be predictions afterwards, is meaning that we can't even fathom what is
it's
after it?
that formal models don't work. So when you say technological singularity, that phrase means it is a technology that is introduced into the world that our models of previous interactions with technology don't work on a sociological level. So, by that definition, we've had plenty of technological singularities. Like, try and ask someone before the invention of cell phones what they think the world would be like if everyone had a phone in their pocket. And they probably talk a lot about everyone having conference calls all the time because they could not have imagined text messaging. They could not have imagined social media. When we say technological singularity, we're talking about the introduction of a technology that will change society in a way that is completely unpredictable. Colloquially, it means, hyper intelligence and mind uploads and all that kind of sci-fi goodness. But when you say technological singularity, what you're really talking about is a technology that we can't predict what it's going to do to society. And artificial general intelligence, AGI. Last time, lots of people listen to the podcast. The last podcast, when I mentioned that anyone who understands the phrase AGI really needs to touch grass, everyone thought that joke was funny, and I'm going to say it again.
There you
So,
go.
but
Trademark it right now.
yeah, trademark it right there. But what I meant by that is it's a it's I think there's this tendency to kind of like work yourself up and get like too worried about something that is probably not going to happen in the near to medium future. And so if you're worried about artificial general intelligence, you probably shouldn't be. And for reasons we'll get into shortly. But the goal of artificial general intelligence is you have just one AI system, one artificially intelligent system that if you prompt it with a problem, it can come back with a solution to that problem. That's the input is anything, and the output is a solution. it can. So right now, our artificial intelligence systems exist the way they do because they have consumed, processed, and interpreted human knowledge. And the goal is to return relevant knowledge. And what makes this so exciting from like a research perspective for example, scientists and engineers, is that this system is able to make connections that are beyond the scope of a single human intelligence to like put together factors that all of humanity has observed. So connections between, interactions between proteins for a organic chemist. Like organic chemistry is like one of the hardest things that exists in science. And there's a small number of people who truly understand organic chemistry. And the promise of these kinds of engines, these tools, is that they can see connections in physical phenomenon that humans might need to be like a polymath to understand on their own. So even as good as these systems are, they are not general intelligences. They are very specialized intelligences. And the innovations that they come out with are the result of interactions between human observations that individual humans have not noticed. And the promise of and again, general intelligence is something that would be able to research new information that is not already within its corpus. And this is not necessary, and this is slightly different from plugging it into the internet to go do a search, to go do a live search. Again, that's not really what we're talking about with a general intelligence. And the way language models work, I don't see that as a route to a general intelligence, just because it is only a statistical analysis of what it already knows. It can't improve, it can find connections that we didn't notice, but it can't find out new things. And that would be part of a general intelligence. Is that a fair assessment?
Oh, that was fantastic. I mean, I feel like I just really learned what was going on instead of somebody trying to tell me a sci-fi version of all this stuff when you go on to it. Anytime I look up, AGI, all of a sudden, you know how it is. They get crazy with it, right? So the way you mentioned singularity too, it's just shocking that more people don't speak to it like that. And it with the phones, however you want to take it, better than maybe what some have predicted. And the part two, Jamison, I'd love for you to dive in there and get your inputs too. Charles mentioned that Gen AI is not the route towards AGI, right? Is not on the same route, I guess, correct? What do you think about that, Jamison, or your inputs on AGI overall?
Yeah, definitely. I love this conversation. This is a great topic. So I definitely agree with Charles for the most part, for sure. I see AGI as more of an event, right? Just like with phones and the internet is an event that definitely changes how things work afterwards because it's so wide reaching, right? So definitely agree there. With language models, with generative AI for sure, I see that as like a really interesting and novel application at the moment, and for a while it will be on the forefront of what we're doing with just AI progress, right? Which is great, but eventually it'll be like Excel or like Photoshop, right? And it's just it'll be mundane, but people will still use it, right? It'll still be important. And I think when it comes to like what I see in the future with AGI is seeing as more machine learning sort of delves into different areas of science, down all the way down to quantum physics, and then organic chemistry as well, and molecular biology, all that kind of stuff, going all the way up to the more abstract sciences like linguistics and sociology, all of that stuff, being able to make connections at a variety of different levels there, that is sort of what I see as the event of artificial general intelligence. And I mean, we've had this kind of convergence with science. People, a lot of scientists sort of are in favor of being able to expand, create more general language as opposed to each individual field having like a particular scientific jargon, sort of, and being able to communicate between fields to sort of stitch them together a little bit more. But this helps a lot with that, like a lot, especially the language models. And I think I see language as being that connection, right? That thread that actually brings those areas of science together to be able to make the predictions that Charles said before, where we can't conceivably be able to think about all that kind of stuff at the same time, where we're able to build out that foundation of knowledge and provide that data through collection and manipulation. But we need this kind of structure, and I think it's going to take a while to accomplish, but I do see that I see that happening, just like I see I didn't see the internet happening because I wasn't born at that point, but I do see this one happening for sure.
Interesting. And by the way, Jamison casually mentioning all the fields like linguistics that he's a alumnus in, as well. So, yeah, I mean, so you're almost more so on the side that you do see it coming sooner.
I would say it's sort of a process, right? The more that we're able to strengthen these lines of communication, the more kinds of discoveries that we're going to be able to make, the more stuff we're going to be able to make. And that's what really drives progress when it comes to being in society, right? The internet definitely drove progress because it connected a lot more people. And this is going to be doing the same thing. It's just going to be on a different level.
Okay. All right. And I know this is now definitely our longest podcast, but in a wrap up, right? I think it's also potentially the most interesting for our current state that we're in. Generative AI as a whole, right? Jameson kind of got your feel for a little bit of where it's going with the blend. Charlie, you want to go, and then we'll wrap up with Jameson. Generative AI as a whole. What is the next logical step? And fast forward, I guess, probably 2 months from now. What's the next podcast? We'll be chatting about it this rate. But what's the next
Fair enough.
logical step for a generative AI?
So the way so I think we've kind of the science right now has kind of hit a plateau. We had some explosive growth at the end of 2022 into the beginning of 2023. Like, you're not going to see something on unless something unless some real innovation is unlocked very soon. We're probably not going to see the kind of explosive growth from end of 2022, early 2023. What's going to happen now is integrations. What's going to happen now is tools that are going to use the part that I'm most excited about is this way of natural language processing being converted to explicit machine commands. This will open up a lot of powerful computation to people who don't necessarily have the time to know compute the specifics of computer syntax. So the ways in which we're connecting these specialized tools to general language is probably going to drive a lot of the innovation. One thing that Jamison and I have been talking about a lot, Wolfram. Wolfram, very, very powerful mathematics suite that is very, very finicky to use. But if you can translate what math you want to do to GPT to Wolfram, that is going to be extremely beneficial. It's going to be extremely powerful for a lot of disciplines. So we're going to probably see a lot of that, like opening up tools that were prohibitively hard to use to more general people, to more general to more people who can get to more people who can get benefit out of it. That's the way I wanted to phrase it.
Fantastic.
And we're also going to see a lot of very stupid things. I'm sorry. I'm sorry. The next few years, we're going to see a lot of like really, really useless gimmicks that get plugged into ChatGPT. I'm just warning everyone now. We're going to see a lot of like cash grab things that don't benefit anyone, but they'll be powered by AI, and that's going to be just a big marketing buzzword. And so be careful out there. And by the way, if you were curious, the thing I was disappointed about in Google I/O, integrating this into Google search is, I think, a bad idea. When I go to a Google search, I'm doing it to find primary sources, not not what Google thinks all the primary sources are saying. So, like I said, we're going to see a lot of great integrations, and we're also going to see a lot of really not good ideas that won't last very long.
I mean, before I pass over to Jamison, I mean, if you guys remember when crypto first was really, really popular, and I think companies were changing their official names to have the word crypto or Bitcoin in there. Their stocks rose to the sky, and then the next week they're gone. So just a little bit of a heads up, right? A little foreshadowing. I think, Charles, that's great. I really already feel like some of the plugins are useless that were recently released. What is this? So thank you for that, Charlie. That would be amazing for the good side of that. Jamison, taking us home.
Yeah, sure. Yeah, I mean, as mentioned, we're in the integration phase at this point when it comes to this type of technology. We've with the first phase with academia, we were in the discovery phase. We've gone through that. We've gone through the growth phase with corporations being able to monetize this to the point where they're making gigantic machines that they have these models on them. And now we're in the integration phase where everything is sort of incorporating into the rest of the internet and the rest of society as we see when we talk about it in real life all the time at this point. I'm able to mention it to people who definitely don't work in this field, and they talk about it too. And that's definitely something for sure. So it's making waves, but I'm definitely excited for once this solidifies and once we're able to make sure that it works well and is reliable, what we can do after this, what we can do next with this kind of technology, with the foundations and what we learn here, what we're able to do next after this.
And at this rate, we're going to find out soon. I will tell you, gentlemen, every time I'm with you both, I learn so much. And it's always so much fun. I think we could do this for, another hour, 2 hours, whatever it may be. But any last comments by either of you before we close up shop? Charles?
There is a point that I would like to finish us off on. And that is, I want everyone to understand, I want everyone to have a perspective on this. And it's a perspective that I think is important. When we're talking about generative AI, there are two components of it. We have been very good at understanding the first component, that is the machine. The machine, what it's doing, and the machine is taking our words and giving a response. We intuitively understand the machine, what the machine is responsible for. But I want everyone to also internalize the other half, the other part of this machine. Because obviously, that first part was hard to make. Brilliant scientists needed to work on that part. But the other part, these machines would not work without this second component, and that second component is us. all of us, everything that we have ever written on paper, everything that we have ever written on the internet, the generative AI would not work if it wasn't for everything that we have made. When you're getting a response from a computer, from a generative AI, it is the result of human contribution to the world.
And Charles, that's a great way of putting it. And so with that being said, gentlemen, we'll do this again soon, it sounds like. But for Jamison, Charles, I'm Rich Bowers. This is Corporate Bytes. Thank you, guys. Take care, everybody.
Thanks, Rich. Thanks, Charles.
Thank you.